Hello everyone, welcome back to the channel. Today, we are diving deep into a comparison that has captured the attention of military aviation enthusiasts worldwide, the next era of air superiority, as we examine the F-35I Lightning II and the Russian Su-57. These two fifth-generation fighters represent the pinnacle of modern air combat technology. Yet they approach the concept of air superiority from two very different philosophies. The F-35I, derived from the American F-35 platform, emphasizes stealth, sensor fusion, and multi-role versatility, while the Su-57 is a product of Russian design philosophy, focusing on super maneuverability, high-speed interception, and a balance of stealth with raw performance. By the end of this video, you'll have a thorough understanding of how these two aircraft stack up in multiple dimensions, from design philosophy to combat potential, and what this means for the future of aerial warfare. The F-35I is part of the larger F-35 family, which includes the F-35A, F-35B, and F-35C variants. The F-35I specifically refers to an export variant customized for the Israeli Air Force, featuring advanced electronic warfare capabilities and locally produced systems. One of the primary strengths of the F-35 series is its stealth technology. The airframe is designed with radar, absorbent materials, and angular surfaces to minimize radar cross-section, allowing it to approach enemy airspace with reduced detection risk. Its single engine is optimized not just for speed, but for efficiency and reliability, making it an ideal platform for extended missions. The aircraft is also equipped with an array of sensors, including radar, infrared, and electronic warfare systems, all integrated through a sophisticated avionics suite. This integration allows pilots to see the battlefield like never before, fusing data from multiple sources into a single, intuitive interface. The Su-57, on the other hand, is Russia's first true fifth-generation fighter, designed to counter the growing capabilities of Western aircraft. Unlike the F-35, the Su-57 emphasizes super maneuverability, achieved through thrust, vectoring engines, and advanced aerodynamics. Its twin-engine design provides significant thrust, allowing for incredible acceleration and sustained high-speed flight. While stealth is incorporated into the Su-57, Russian designers opted for a compromise, accepting a slightly higher radar cross-section in exchange for greater agility and payload capacity. The Su-57 can carry a variety of air-to-air and air-to-ground weapons, including hypersonic missiles, and is equipped with a sensor suite capable of long-range target detection and electronic countermeasures. The aircraft is designed to operate in contested airspace, engaging both high-value targets and enemy fighters with a combination of speed, stealth, and maneuverability. One of the key differences between the F-35I and the Su-57 lies in their operational philosophy. The F-35I is designed to dominate the battlefield by controlling information. Its sensors can detect threats at long ranges, relay data to other assets, and guide weapons with incredible precision. Essentially, the F-35I acts as a force multiplier, enhancing the effectiveness of Allied aircraft and ground systems. This is particularly important in modern air combat, where the ability to detect and engage before being detected is often the decisive factor. The Su-57, conversely, is built to thrive in a direct engagement scenario. Its maneuverability allows it to survive close-range dogfights where traditional air combat skills are still relevant. While it can operate as part of a networked force, the Su-57 retains the ability to independently engage multiple targets and evade threats using speed and agility. The cockpit experience in the F-35I is another area where the aircraft sets itself apart. Pilots benefit from a helmet-mounted display that projects critical flight data directly onto the visor, allowing them to maintain situational awareness without looking down at instruments. This feature, combined with the aircraft's sensor fusion capabilities, means that pilots can track enemy positions, incoming threats, and mission objectives in real time. The F-35I's avionics are designed for simplicity without sacrificing capability, reducing pilot workload while maximizing combat effectiveness. In contrast, the Su-57 cockpit incorporates more traditional analog controls alongside modern digital interfaces, giving pilots more tactile control over the aircraft in high-intensity situations. Russian designers emphasize pilot skill and adaptability, ensuring that the aircraft can perform under conditions where automated systems might fail or be jammed. When it comes to stealth, the F-35I is generally considered superior. Its low observable characteristics make it difficult for even advanced radar systems to detect, giving it a significant advantage in initial strike scenarios. The Su-57, while incorporating stealth features such as radar, absorbing coatings and internal weapons bays, has a slightly larger radar signature, particularly from certain angles. This means that in a head-to-head scenario where both aircraft are aware of each other, the F-35I might gain the upper hand in the initial engagement. However, the Su-57's superior speed and maneuverability could allow it to evade attacks or reposition quickly, complicating the engagement dynamics. Weapon systems on both aircraft reflect their design priorities. The F-35I carries a mix of air-to-air missiles, precision-guided bombs, and electronic warfare pods. Its ability to launch weapons from internal bays maintains its stealth profile, crucial for penetrating heavily defended airspace. Israeli modifications add advanced electronic countermeasures and specialized munitions, enhancing its role as both a strike and defensive asset. The Su-57, meanwhile, has larger internal bays to accommodate a diverse arsenal, including long-range missiles, air-to-ground ordnance, and even experimental hypersonic weapons. Its twin-engine design also allows for higher payloads without significantly affecting performance. While its stealth is slightly compromised by these larger payloads, the Su-57 compensates with agility and raw firepower, making it a formidable opponent in both offensive and defensive operations. Speed and maneuverability are another critical area of comparison. The F-35I can reach speeds of around Mach 1.6, which is sufficient for most combat scenarios but not designed for prolonged supersonic flight. Its emphasis is on stealth, sensor dominance, and multi-role versatility rather than sheer speed. The Su-57, with its supercruise capability, can sustain supersonic flight without afterburners, giving it a tactical advantage in intercepting targets or evading threats. Thrust vectoring allows the Su-57 to perform extreme maneuvers that would overwhelm most other aircraft, giving it a unique edge in dogfights. While these capabilities might seem less relevant in an era dominated by beyond visual range engagements, history has shown that close encounters still occur, making agility a significant factor in survivability. Avionics and electronic warfare are areas where the F-35I excels. Its radar, known as the AN/APG-81 ESA, provides long-range detection, tracking, and targeting capabilities. Combined with electronic countermeasures and data link integration, the aircraft can effectively control the electromagnetic spectrum, disrupting enemy radars and communications. The Su-57 is equipped with its own radar system, the N036 Bielka, which incorporates active electronically scanned arrays for both air-to-air and air-to-ground operations. While powerful, Russian systems traditionally lag slightly behind Western equivalents in integration and network-centric capabilities. However, the Su-57 compensates with robust electronic countermeasures designed to survive in heavily contested environments, ensuring it remains operational even when facing advanced detection systems. Operational range and endurance also highlight the different design approaches. The F-35I has a combat radius of roughly 650 nautical miles, suitable for the majority of missions but requiring careful planning for extended operations. Its fuel efficiency is enhanced by a single engine configuration and aerodynamic design, which also helps maintain stealth. The Su-57 has a slightly longer combat radius, supported by its twin engines and higher fuel capacity, allowing it to operate over vast distances without refueling. This endurance, combined with its payload flexibility, allows the Su-57 to conduct longer patrols, deep strikes, or sustained air superiority missions, reflecting Russian doctrine which often emphasizes strategic reach and autonomy. Maintenance and logistics play a critical role in sustained operations. The F-35I benefits from a global support network with standardized parts, diagnostic systems, and trained personnel ensuring high availability rates. The aircraft's software-driven maintenance protocols also help identify issues before they become critical, reducing downtime. The Su-57, being a newer and more complex system with fewer operational units, may face challenges in maintenance and logistics. Russian aircraft often require more hands-on attention and may experience lower operational readiness rates, particularly in harsh operational environments. However, the Su-57's robust design can tolerate more stress and damage in combat, reflecting a trade-off between ease of maintenance and combat durability. Another interesting aspect is the future upgrade potential of both aircraft. The F-35I is built on a software-centric platform, allowing for continuous improvements to avionics, sensor fusion, and electronic warfare capabilities without major airframe modifications. This modular approach ensures that the aircraft remains relevant against evolving threats. The Su-57 also has a growth path, including the integration of more advanced engines, hypersonic weapons, and improved stealth coatings. While software upgrades are less emphasized compared to the F-35I, Russian designers have focused on adaptability, ensuring the airframe can incorporate emerging technologies without extensive redesign. When considering combat scenarios, the strengths and weaknesses of each aircraft become apparent. In beyond visual range engagements, the F-35I holds a significant advantage, leveraging stealth, advanced sensors, and networked operations to detect and engage enemies before being detected. This first look, first shot advantage is central to Western air combat doctrine. In contrast, the Su-57 shines in contested environments where stealth alone may not guarantee success. Its speed, maneuverability, and robust defensive systems allow it to survive engagements even when detected, emphasizing survivability and adaptability. If these two aircraft were to meet in a theoretical engagement, the outcome would depend heavily on the context, distance, terrain, supporting assets, and pilot skill would all play decisive roles. International deployment and doctrine further illustrate the differences. The F-35I is designed to operate as part of an integrated air force, relying on satellites, AWACS, and allied platforms for maximum effectiveness. Its operational philosophy emphasizes precision, information dominance, and coordinated strikes. The Su-57, while capable of networked operations, is also designed for independent action, reflecting Russian doctrine that often emphasizes flexibility, resilience, and self-sufficiency. Both approaches have merits, and each aircraft is optimized for the strategic priorities of its respective nation. Another consideration is cost and production scale. The F-35I, while expensive on a per-unit basis, benefits from economies of scale, as the broader F-35 program produces hundreds of aircraft for multiple nations. This standardization reduces overall operational costs and ensures a steady supply of parts and upgrades. The Su-57, with far fewer units produced and higher development costs, faces limitations in availability and fleet size. However, the Russian strategy often focuses on deploying a smaller number of highly capable aircraft to achieve strategic deterrence, rather than relying solely on quantity. In terms of survivability, both aircraft incorporate unique approaches. The F-35I relies on stealth, situational awareness, and electronic countermeasures to avoid being engaged in the first place. Its philosophy is avoid detection, dominate from a distance. The Su-57, in contrast, accepts that detection is inevitable in some scenarios and instead emphasizes speed, maneuverability, and robust defensive systems to survive engagements. This approach can be seen as more traditional, relying on pilot skill and aircraft performance in addition to technology. Considering pilot training and human factors, the F-35I offers a high degree of automation and support, reducing pilot workload and allowing even less experienced pilots to operate effectively in complex combat environments. The Su-57, by design, places more responsibility on the pilot, reflecting a doctrine that values human decision-making in high-stress, dynamic engagements. Both approaches have advantages. Automation enhances consistency and safety, while human-centric design allows for flexibility and creativity in unpredictable situations. Looking ahead, the next era of air superiority will likely see both aircraft evolving in response to emerging threats. For the F-35I, this may include further enhancements to stealth, electronic warfare, and integration with unmanned systems. The Su-57 may continue to push the boundaries of speed, maneuverability, and hypersonic weapon integration. Both platforms demonstrate that the future of aerial combat will not rely solely on one approach, but on a combination of stealth, firepower, information dominance, and pilot skill. In conclusion, comparing the F-35I and Su-57 offers a fascinating insight into the contrasting philosophies of air superiority. The F-35I emphasizes stealth, sensor fusion, and multi-role versatility, excelling in beyond visual, range engagements, and networked operations. The Su-57 prioritizes speed, maneuverability, and survivability, capable of thriving in contested environments and close-range dogfights. Each aircraft is a product of its nation's strategic doctrine, technological priorities, and operational requirements. While a direct confrontation between the two would depend on numerous variables, both represent the cutting edge of fifth-generation fighter design and will play pivotal roles in shaping the future of air combat. Ultimately, understanding these differences is key to appreciating how air superiority will evolve in the coming decades, highlighting that technological innovation, strategic doctrine, and pilot skill remain central to dominance in the skies.